Yes.
Are they like corresponding like just each
Yes, sir.
above it goes with that one?
This one is paired with that one. Yeah, and that's why we don't want to lose that. We want to do this matched pair idea because we want to maintain that. Yes, that is very, very important. You're about to see one that's even more obvious when I have you guys generate your own data in a second here. Yes, very, very important. Good? Good. Now, let's run a t-test. All right, it's just a t-test like it was last week. We have data, just like we did at the end of last week. We're going to test versus 0. I don't know why mine says 0 right now, but it does. It's wonderful. Yours probably still says 30, I'm guessing, because that's the last thing we did. I don't know why mine changed. List, L3. Make sure to point your TI to the correct list. Frequency, definitely 1. Raw data. Raw data. Let it test the claim that we're greater than 0. Do you see how we could have tested this at less than 0 if we wanted to? We would have had to subtract the lists in the other direction. That's the discussion we had earlier about the difference between... The problem is the word difference in mathematics is not switchable. You can't just decide which one goes first. Whatever one's first is then taken away from the one that's listed second. So, or I said that backwards. Whatever one is first is lessened by the one that comes second. Okay? You guys like draw, I think. Let's do it! Oh crap, I got my... No, whatever. That's fine. The histogram and the damn box plot are still on, but I think you guys can see what's going on. We're looking for... Oh! We're looking for area. We got some. You now have a test statistic and a p-value, yes? Don't forget the variable! T. There's a reason why I'm making you write the variable on your quizzes. What is that reason? Because I'm a bastard? Maybe. Where are you going to see those variables? This is maybe it's a loaded question. In the journals you read. When you read the journals, you're going to see these variables, and I want you to be able to cut through the lingo and the jargon and realize, oh, they said t equals negative, whatever this is, negative 1.08. As Michael Berg correctly said a few moments ago, and I say a few moments ago, I mean 45 minutes ago, 1.08 what? Or 1.09 what? What is that a measure of? It's not decibels, it's standard deviations from 0. Good. Yeah, that's what Michael drew the distinction before, which was great. Is that it's not a decibel measure. We've actually removed the decibel measure and made it standardized. So it's a standard deviation away, which is far or not far statistically. That's not considered far enough to be unusual, nah? And you can see that replicated in your p-value. Your p-value is big or small? It's big! We're comparing it to 5%. It's big! It's big! It's big. Skylar?
Does this mean that the probability that the data agrees with the null hypothesis
is the 14%, exactly. Now, Skylar's going to say correctly, but I don't think that's small enough. Maybe that's still pretty small. And that's where you can decide before you run your test. You might want to decrease confidence. Can we come back to that question? It's a very good point. Let's finish this up. I want to come back and look at this 2 different ways. Yes, let's hold that thought. Yeah, you got it. So in other words, by a 5% standard, there's enough agreement to think that we can't believe this. So we believe this. But to Skylar's standard, she's like, it's still not small enough. But we'll come back to that if you don't mind. Fair? Fair. Just pause for a moment. Let's finish this bad boy out. We got a p-value, 14%, 14.5%, which is bigger than 5%. So does it appear or not appear? It does not appear that TV commercials are significantly louder than their, beautiful Lauren, than their shows. It does not appear that TV commercials are significantly louder than their shows. Could we be wrong? Of course we could. We can always be wrong. That's why this class is called statistics, not parameters. Which kind of error could we make? Definitely a type 2. We got a big p-value. We got a big p-value, which means maybe they are wrong. Maybe they are louder and we missed it. Maybe they are louder and we missed it, which comes back to Skylar's point. I want to hit a couple things right now. First, Skylar, because the question you just asked. Then I want to go back to a point we had earlier. But first, any questions on this, on the wrap-up of this right here? We okay with this?
There's a thing in your stats and it's 2 sample t-tests.
There is! That's a third question. Could we put that in the queue if you don't mind, Lauren?
Okay.
Lauren's got a great question. I want to talk about that in a moment.